Hello. Today we're going to learn about classes and structs or structures in C++, and later we will learn about Python. Remember that now that we know how to make functions, we can create structures and classes which are very useful in object programming languages. So what is a C++ struct? Structs are the basis of classes. For example, an NBA player for a video game. Say you have to design the video game and you're going to use a player. You can copy and paste the player several times and change the attributes. Hair color, height, weight, team jersey, shoes, etc. All players have functions such as jump and run, shoot. So constructs are called to create an instance of the object. Classes can have private or public specifiers. The attributes are assigned with colon operator after the object name. Struct. So the way to create a struct is going to be with the curly brackets open and close, and we're gonna name the struct. Notice that after the struct, you create the name, but you don't add the semicolon. You add the curly brackets. Then within the curly brackets, you have the string name and the float or the variable name and type of variable that you want to add. But after the curly bracket, you do add the semicolon. And then you can create a student that will have the attributes of the struct. So students and students1. Students1 is going to be the name, students is calling the struct. You can have multiple data types, such as string, floats, etc. So for instance, you can have the object say Tom, Carrie, Aaron, etc. And then you have the GPA for all of them. So the string is the name, the float is the GPA. So let's look at this example. Let's open dev++ and let's create our code. And then we're gonna add our first line, which is gonna be, of course, the include. And it's gonna be the C standard input output. And then we're gonna create a first struct. So struct lowercase and name, we're gonna say just S, and we're gonna have open close curly brackets. At the end, we add the semicolon. So we're gonna have a variable called int I, and we're gonna have a double called d, and we'll have a char, which is gonna be type const, which is going to be a pointer called s. Then when we create a function, we're gonna have int main, and then of course the curly brackets, so int and curly brackets. Then we're gonna say our first object is gonna be from calling the structure s. Then we're gonna say s1 equals 3 comma 47.9 comma string 1. All right, and then we add the semicolon, and we can say print f, and then we can say s1 equals or is percent d comma percent f for the float comma percent string backslash n, and then we're gonna print the values, which are of course s1 comma I comma d comma we're gonna do, and then we're gonna print the value, which is si.I, so we can access the struct, then si comma dot d, s1 dot d, correct, comma s1 dot s, right? And then we can basically call this and compile it. And when we run it, we're gonna show that we're gonna have s1, s3, 47, string 1. So then when we change the values, we can say, for example, s1.d, so the double now is going to be 71.1, and s1 string is going to be string 2. So when we print the same thing, so let's copy paste the line, we can basically recompile it, and we're going to say int main, we're going to say printf, where we need to add the semicolon here. So we say recompile, run, and then we have the new values 371 and string 1. It's because we didn't change the int, which we could have. And we just needed to show you that the int will stay untouched. But if you update it, then of course it's going to have a different value, and this is the s1i, correct? And this is now going to be 1 instead of 3. So let's recompile it and rerun it, and now we have 1. So another example is right here, where we're going to create a struct called students, and it's pretty much the same. Let's go ahead and create a struct for that, where we create a new code, and we're going to include the input output stream in this case, and we're going to say using namespace so that we can use the C output standard. And the same thing we said before, we're going to say struct to generate our structure and students. So no semicolon, but we open, close curly brackets, and then we do the semicolon there. So first of all, we're going to have a string called name, semicolon, and then we're going to have a float, which is going to be G. 3, 2, 1, go. And then we're going to have a float, which is GPA, and we're going to say int main. We're going to have open, close brackets, and now this main is not going to have the curly, it's not going to have the semicolon at the end because it's the main function. So we just need to initialize the struct calling students, and we say graduate. And if you notice the code right here, we can basically say, so graduate name, graduate dot name equals Mr. Tom. All right, and then we're gonna say student intro to prog. It's gonna be, say, 10 students, and then we're gonna say the first position is gonna be into the prog, let's say position 0. So the first one is gonna be enter position 0, and then we're gonna say dot name equals Jerry, and then we're gonna say into program in position 0, but for GPA, we're gonna have that Jerry has a 4.0, and don't forget your semicolon and your semicolon here. Okay, so when we do a printf or a cout, we can say printf. We can say intro to prog and position 0 dot, because we're gonna access the GPA, equals a %f for float. So this is going to be basically printing that. So copy paste, and don't forget the semicolon, and I'll return 0. And also have to do the open close, return 0, and make sure that I have this. Oh, I did, yes, here. Whoops. Okay, so if I try to compile this, it's gonna ask me for example 1 and 2, and then I have an error, student. Oh, it's because I'll type in error students. Let's try to compile again, and then student intro to prog, another one here, semicolon that I need to add, and then I have return 0, too many curly brackets. Okay, when I run this, into the program is 4.0, or then I can say Jerry has a GPA equal to, compile, we run, and Jerry has a GPA equal to. So let's look at this code again. So we create the construct, which is going to be named students, or student. You can just remove it and just make one student, and plural. It just make sure you remove all the s's here. And then it's going to have a string name and a float GPA. When you call the struct, we're going to say students, and it's going to be called graduate. Therefore, when you access the objects, you're going to use graduate.name, which is going to be this, and graduate.gpa. But we're going to say that students is going to be an array, and the first position is going to be for Jerry, and it's going to have GPA of 4.0. So you can do the second one for Tom, for their third one for something else, but then you can print the array, and that's what we did. Another one that we can look at, and this one is perhaps an interesting one because is using a function. So now we can create an example of a class, and in that case we're gonna use the private and we're gonna use the public. So 3, 2, 1, go. So the private is gonna be the float balance, and the public is gonna be the function bank account. So let's now create a class which is going to be the bank account. So new file, source file, and now we're gonna do include input output stream, and we're gonna say using name space standard, just as before, and we're gonna call this class bank account, no semicolon. But in this case, we also need the curly brackets, and at the end, of course, we need the semicolon. So first of all, we're going to say that it's a private variable, and it's going to be called float balance, which is balance is the name, but type float. All right, oops, balance, semicolon. All right, and then we're going to say a public instance so that every aspect of the class can see it. Is going to be the function bank account. So bank account. Okay, so we're going to do void. Type void is going to be deposit, and we're going to input a float, and we're going to do another one which is void withdraw, and withdraw, and then we're going to do float get balance. So float, this is a type float function, so this function is type void, this is void as type void. These so two functions type void, one function type float, and that one is called get balance. And of course that makes sense because it's going to return something, so we're going to return a float for the balance, and then we're going to do a void, a function with a void return interest, accessing which you access a float. Okay, so that is our public initialization of the functions. So when we say bank account, I'm going to use the colon for the construct bank account. Okay, so when we create our function from the construct, we're going to say balance equals 0.0. So first the balance is 0.0. All right, then we're going to create our next one, which is going to be float, and then we said bank account column, and then we're going to say get balance. Okay, so we're going to do open close curly brackets, and we're going to return balance, and the balance is a private variable. So what we need to do is a function that would make deposit to a balance. So we're going to say void bank account column deposit, and we're going to have a float which is deposit, which that makes it a function that is going to have a balance equals plus equals deposit. Okay, and then lastly we have a void function that will have interest, and we're going to have a float interest, and what that will do is that will open up and close brackets, and we'll say balance is equal to balance times, let's say 1 plus the interest divided by 100, semicolon, and then we can compile this one and say bank account plus, let's see what errors we get. So bank account, let's see, bank account, we initialize the construct bank account, so we are initializing the bank account with a construct. We're gonna say the balance is 0.0, and we forgot the bank account. Oh, okay, well we need to write this down first. Bank account. Okay, balance is plus equals deposit, and this is void bank account deposit, which is in arena float, and balance is plus equals deposit. What is the error here? Let me see. It says balance was not declared in this scope, but balance, I thought it was a private float. So indeed it should be declared in this scope because it is a private variable. So when I go ahead and check, I have a private balance and I have a float. And this balance was not declared in the scope. Deposit up here is gonna get a float as an input, and that float is the deposit. Okay, so there's an error here, which is void float interest. Oh, this is balance. Okay. Now, void interest. And we have void interest, which is interest. Oh, okay, this is capital I. Capital I. Alright, and then balance, another typo here. Balance and alright. Oh, there's an error one. Exit status error in main. Let's see. Exit error here, and that's because we don't have a main function, so we have to go ahead and get our main function here. So let's create our let's go ahead and check our main function here. Int main. So int deposit is going to be equal 0, and then we're going to say bank account is going to be initializing now an object called checking, and then we're going to say another one is going to be bank account for savings. Okay, then we have a cout where we're going to output from that cout the following line. Checking balance is, so the checking balance is, and then we will say that can be asked for at savings dot get balance. Right. So for instance, if we were to compile this now, we would have an error because says cout is not giving return 0, and then we have to run cout. Let me see. Check savings. Oh, it has capital S. We have to be careful about those type of things. So savings can run now, yeah. So when we run it, we say this checking balance is 0, and that is basically because we have an in deposit, we have a checkings and savings, and we said savings that get balance. So get balance is going to come to this function is going to return balance, but balance is 0. Okay, savings get balance, and balance is from the class bank account. All right, so we can keep going. And now we're going to say cout. Cout is enter or deposit amount, I guess is better, deposit amount. Okay, and then we're gonna say so and line, and then we're gonna get input from the user where we're gonna stick it to deposit. So the input is the deposit variable, which is an int, and yeah, okay, that's okay. Actually, we can say the next thing that we can do is checking, so we can input the checking, which is checking dot deposit, correct? I'm gonna enter the 100, for example. Say we deposit 100, and then we can say savings, which is with capital S, savings dot deposit, and ask for the variable deposit. And we have this particular point, we can print some other stuff. So let's print on cout, and let's do an end of line, enter. Okay, and then going here, and we're gonna say checking balance is, and then we're gonna say checking dot get balance is, and then we're going to ask for the balance from the function get balance, which is up here. Notice the get balance is having a void in argument, and is going to return the balance. So then we get that. The only thing we have to do is ask for the savings, which is the next line. So here we're going to do savings, and it's going to be savings balance is, so savings dot get balance. Okay, excellent. End of line, end of line. And let's say that we're gonna say, okay, well, sorry, but the savings has capital S. Then down here we're gonna say savings dot inter, there you go, interest is gonna be 3%. Okay, so we can say cout is the savings after interest is savings after interest is. Alright, so what we say is, in this case, is going to be under savings, get balance as well. But in this particular case, we can do return 0, which I think we already have it. Yes, and then we can compile. So let's see what errors we got. Cout, not count. Excellent. So no errors. We can run it, and then say deposit amount. So $100. So checking balance is $100. Saving balance is $100, and this is 3%. Is going to be by 303. So let's look at the code one last time. And is the class is going to call, it's called bank account, and balance is a private variable, meaning that is going to be used privately by each function. And then public is everybody can see it, therefore the arguments and the outputs can be shared. In our bank account, which is the construct for the class bank account, and we're going to have a function deposit with argument float and output void, withdrawal, which is argument no argument and type void return, and get balance, which is going to be float return, and void function interest, which has a float argument. So bank account, we're basically initializing the construct, and we start with balance 0. Then we create a float return bank account get balance. So the object get balance from the instance get account is going to return the balance at this point. So this is a function is going to get balance every time. And then we're going to get a bank account deposit. So we're going to have an argument of deposit as a float. It's going to add to the balance. And then the bank account interest, which is going to be void output, but an argument float, is going to basically compute the compound interest. So in our main function, we just have a deposit, initialization, and then we're going to say bank account is going to have an object checking and an object saving. And then we ask for the saving with case get balance, and we make a deposit. We we make the deposit. So it's basically this line right here, the check-ins and the savings, and we're saying the checking balance is such and the savings balance is such. Okay, and at the end it's computing the interest.